In the last lesson, we learned how to ask a single, simple question. We can check if score is greater than 100 and get a result. 1, true, or 0, false. But in the real world, logic is rarely that simple. We don't just ask one question. We ask compound questions like, to open this door, does the player have the key and is the power on? To win the game, has the player defeated the boss or collected 1,000 coins? How do we combine these separate true, false answers into one final decision? For that, we need logical operators. Welcome to Lesson 2.07. Today, we are mastering the final set of operators which allow us to build complex, intelligent logic. Logical operators do not operate on numbers like 10 or 5. Instead, they operate on the results of comparisons. They work directly with the true 1 and false 0 values. We will cover the 3 essential logical operators: logical and logical or logical not. First, logical and the strict operator. The AND operator is the strict one. It checks if all conditions are true. If even one condition is false, the entire expression becomes false. Think of it as, I need this to be true and that to be true too. True and true equals true. True and false equals false. False and true equals false. False and false equals false. Example, integer score equals 500. Integer hasty equals 1. Integer result equals, score is greater than 100, and hasty is equal to 1. Is score greater than 100? Yes, true. Is hasty equal to 1? Yes, true. Because both sides are true, result will be 1 true. Second, logical or the lenient operator. The OR operator is the easygoing one. It checks if at least one condition is true. The only way it can be false is if all conditions are false. Think of it as, I just need this to be true or that to be true. True or true equals true. True or false equals true. False or true equals true. False or false equals false. Example, integer coins equals 50. Integer has VIP pass equals 1. Integer can enter equals, coins is greater than 1,000, or has VIP pass is equal to 1. Is coins is greater than 1,000? No, false. Is has VIP pass is equal to 1? Yes, true. Because at least one side is true, can enter will be 1 true. Third, logical not, the inverter. The not operator is the simplest. It doesn't combine two things. It just flips or inverts a single value. Turns true into false and false into true. Not true equals false. Not false equals true. Example, this is extremely useful for checking if something is not true. Integer is game over equals 0. Integer can player move equals not is game over. Is game over is 0, false. Not is game over flips that false to 1, true. So, can player move is true. This is a huge milestone. We have now completed our entire toolkit of operators. We can calculate new data, store that data, ask simple questions, and combine those questions. We have all this logic, but our program is still silent. We can't see the results of our calculations. We can't see the final true, false output. How do we make the program communicate with us and show us the value stored in a variable? We used printf, hello, world. But how do we make it print a variable like score? Click on the next video to finally learn how to output our data in Lesson 2.08. Basic data input, output, the printf function, formatted output.